set the equation equal to our leg, and then we divided to solve for x. Solving for x, we could find all three sides. Okay, so let's go back to the packet. And let's try an example. So we're going to try this example here. So in this example, we have to, first, I'm going to draw the triangle they give us. So I have D, F, E, and one side EF is 5 square root 3. What side do they give us? Do they give us the hypotenuse? Do they give us the long leg or the short leg? So we start with this angle. This angle is 30 degrees. And this is the shortest angle, which means that this is the short leg. This is 60 degrees, which means this would be the long leg. And then this is our hypotenuse. If I was to write the formula where the triangle is rotated in this way, I'll do it right here. This is 30, this is 60. So the short leg is x, the long leg is x square root 3, and then the hypotenuse is 2x. So we know x is equal to 5 square root 3. So I could write that here. X equals 5 square root 3. Then I could find all the other sides. So let's start with the long leg. If the long leg is x times the square root of 3, and if x is 5 square root 3, I could write 5 square root 3, so remember that's what x is, times square root 3. Square root 3 times square root 3 is the same thing as 3, and 5 times 3 is 15. So the long leg is 15. Now my hypotenuse, so if I use 2 times x, so 2 times 5 square root 3, 2 times 5 square root 3, I would get 10 square root 3. So to wrap this up, df is equal to 15. de is equal to 10 square root 3. Okay, so what I want to do is I want to go through some of these problems with you guys so that you know how to solve them. The first one we're going to be doing together. Now again, what you have to ask yourself is, are you going to use a 45-45-90 theorem or a 30-60-90? And then why are you using that theorem? So let me copy that problem down. So I have a 60-degree angle here. So because they tell me this is 60 degrees, I know this is a 30, 60, 90. Now, what side do they give us? They actually give us the short leg. And then remember that in the formula, the short leg is x, the long leg is x squared root 3, and then the hypotenuse is 2x. So I know x equals 4. Now you have to be really careful not to mix up this variable for these variables, for this x and for this y. Think of these as question marks. So you know x is 4. If you know that, you could plug in 4 here for x and you would get your long leg. So this would be 4 square root 3. And the hypotenuse is 2 times x. So 2 times 4 is 8. So your answers are 4 square root 3 is the long leg, and 8 is the hypotenuse. And then let's try one more with a 45, 45, 90. So we'll try problem number 4. So just because it looks a little bit difficult, so I have PRQ, and again this is 45, 45, 90, and then I have one of the legs is 2 square root 6. And then on the side, let me just draw the quick formula for 45, 45, 90. So this is x, x, x square root 2. So the legs are x, and what I have in this problem is a leg. I know x equals 2 square root 6. So that means that this has to be 2 square root 6. And the hypotenuse has to be 2 square root 6 times the square root 2. Because remember that this is x, x is 2 square root 6. The hypotenuse though is x times square root of 2. So what we could do here is multiply the square root of 6 times the square root of 2, which would become 2 square root of 12. And I could actually simplify the square root of 12. So I'll do that on the side here. 2 times the square root of 12 is the same as 2 times the square root of 4 times the square root of 3. The square root of 4 is 2, so this is 2 times square root of 3. 2 times 2 is 4. So the hypotenuse ends up being 4 square root 3. So PQ is 4 square root 3, and QR is 2 square root 6. So try the other two problems on your own. Try problem number 2, problem number 3, and then we're going to start the next part of this lesson. So how to use trigonometric ratios of special right triangles.